In this first class of Chapter 4 of the course of Basic Geometry are presented the definitions and properties of the parallelograms. In this first slide of this first class of Chapter 4 of this course of Basic Geometry, in Figure 4.1 is presented a quadrilateral consisting of 4 segments of straight lines that connect the 4 non-collinear points. The 4 non-collinear points are called vertices of the quadrilateral. The segment of straight lines AB, BC, CG, and DA are called sides of the quadrilateral. The angles ABC, BCG, CGA, and GAB are the angles corresponding to the vertices B, C, G, and A of the quadrilateral. Thus, the quadrilateral has 4 sides corresponding to the 4 segments of straight lines, 4 vertices corresponding to the 4 non-collinear points, and 4 angles, each corresponding to one of the vertices. In the second part of this slide, in this first class of Chapter 4, is defined the concept of a concave and convex quadrilateral. A quadrilateral is called convex when the line containing either side of the quadrilateral divides the plane into half planes, and all other sides of the quadrilateral are in the same half plane. Thus, the quadrilateral shown in Figure 4.2 is convex, and the quadrilateral shown in Figure 4.3 is concave. The second slide shows the definition of the perimeter of a quadrilateral. The perimeter of a quadrilateral is defined as the sum of the dimension of the 4 segments of straight lines that form the 4 sides of the quadrilateral. Thus, in the case of a quadrilateral ABCG, shown in Figure 4.4, at the bottom of this slide, the perimeter is the sum of the dimension of the sides AB, BC, CG, and DA. The second part of this slide establishes the calculation of the sum of the interior angle of a quadrilateral. Thus, in Figure 4.4, the quadrilateral is divided into 2 triangles, the triangle ABD and the triangle BCG. The value of the sum of the interior angles of a triangle is 180 degrees, and since the sum of the interior angle of the quadrilateral is equal to the sum of the interior angles of the 2 triangles, the sum of the interior angles of the quadrilateral is equal to twice the sum of the angles of the 2 triangles, which is 360 degrees. This slide shows the calculation of the sum of the exterior angles of a quadrilateral. Figure 4.5 shows the quadrilateral ABCG. In this quadrilateral, the interior and exterior angles are shown. The exterior angle is defined as the angle between the straight line segment extending from one side comprising the vertex, and the straight line segment comprising the other side of the vertex. Thus, the sum of the values of the interior angle with the exterior angle value of the same vertex is 180 degrees, since they are supplementary angles. Then, the sum of the interior angles and the exterior angles of the 4 vertices is 4 multiplied by 180 degrees, which is equal to 2 times 360 degrees. As the sum of the values of the interior angle is 360 degrees, as shown in the previous slide, the total value of exterior angle is 2 times 360 minus the value of the sum of the interior angle, that is 360 degrees. That is, the sum of the values of the exterior angles in a quadrilateral is 360 degrees. This slide shows the definition of a square quadrilateral. Figure 4.6 shows a square quadrilateral or equilateral quadrilateral. The square quadrilateral has the dimension of the 4 sides equal, and the values of the 4 interior angles also equal. In the second half of this slide, the calculation of the interior area of a square quadrilateral is presented. The area is given by the dimension product of the base AB by the dimension of the rays AH, which has the dimension of the side BD. Since the dimensions of the four sides are equal, then the dimension value of the BD side can be replaced by the dimension of the side AB that has the same value. Thus, the value of the area of a square quadrilateral is equal to the value of the dimension of one of the sides, in the case the side AB, that is, the value of the dimension of one side raised to the exponent 2, as shown in the formula. This slide shows the inscribed and circumscribed circumferences of a square quadrilateral. If here are drawn the two diagonals of the square, which are the definition, the lines, segments that join the two non-adjacent vertices of a quadrilateral, the intersection between the two line segments representing diagonals defines the centers of the circumferences inscribed and circumscribed. The inscribed circumference is the circumference that is tangent internally at the midpoint of each of the four sides of the square. The circumscribed circumference passes in the four corners of the square and is outside the square. The diagonals are confused with the bisectors of the internal angles and bisector of the sides of a square. The center defined by the diagonals is the incenter and the circumcenter. A square has four bisectors of interior angles and four bisectors of sides. In this last slide of this first class of chapter 4 of the course of basic geometry shows the definition of a rectangular quadrilateral. A rectangle is defined as a quadrilateral having four right angles and opposite sides with equal dimensions 2 to 2. Thus, in figure 4.9, the right quadrilateral ABCG is represented. The sides AB and CG have the same dimensions and they are opposite. Also, the sides BC and AG have the same dimension and they are opposite. The second half of the slide shows the calculation of the area of a quadrilateral rectangle BCGA shown in figure 4.10. The area of a rectangular quadrilateral is given by the product of the dimension of the segment of the straight line of the base BC by the dimension of the segment of the straight line of a height H, in this case represented by the side CD. This calculation is presented by the formula shown above, figure 4.10.